Hey guys, Mr. Backerberg here. In this video, we're going to look at the product rule for differentiation. So the way the product rule works, let's say you're multiplying together two differentiable functions u and v. So then if we want to take the derivative of u times v, the way it's going to work is we're first going to leave u alone, but then we're going to multiply it by the derivative of v, and then we're going to add to that, leave the v function alone, but multiply it by the derivative of your u function. So this right here is the product rule. U times v prime plus v times u prime. So in this example, we're going to find the derivative for our function f if our f of x function is x squared plus 1 times x cubed plus 3. So in our function, we're multiplying together two separate polynomials. This is our u function, this is our v function. If we want to differentiate this, the way that product rule works is it said take u times the derivative of v, but then add on v times the derivative of u. So if we just work with these polynomial functions that we've got, we're going to end up applying the power rule. So first I want to take u, which is my x squared plus 1, and I'm going to multiply it by the derivative of v. So if I use my power rule in here with that x cubed, I drop the 3 power down, but then I subtract 1 from the power. So I get 3x squared. Now on the back end with that plus 3, if you do the derivative of a constant function, it's just 0. So the whole derivative of v is just 3x squared. But then we have to add on. Now we're going to leave the v function the same. So we're going to leave the x cubed plus 3 the same, and we're going to multiply by the derivative of u. Well, if I differentiate the x squared, I drop the power down, but then subtract 1 from the power. And then if I differentiate the 1, well, the derivative of a constant function is just 0. So the derivative of u just ends up being 2x. Now I'm going to multiply this out and look to combine any like terms. So I'm going to distribute this 3x squared. So 3x squared times x squared is 3x to the 4th. Then 3x squared times 1 is plus 3x squared. 2x times x cubed is plus 2x to the 4th. And then 2x times 3 is plus 6x. Combining like terms, I see 3x to the 4th and 2 more x to the 4th. So we have 5x to the 4th. I don't see anything to combine with the x squared, so we get plus 3x squared. And then I don't see anything to combine with this plain x, so that stays as plus 6x. So the derivative of this function ends up being 5x to the 4th plus 3x squared plus 6x. So in this example, we're going to look at using the product rule again, but we're going to use numerical values. So we're going to let y equals uv be the product of the functions u and v. And what we want to do is differentiate y at 2 if we know that u of 2 is 3, u prime of 2 is equal to -4, v of 2 is 1, and v prime of 2 is 2. Well, if we're looking at that original function, y equals u times v, if I want to find y prime, then the product rule says I would have to do u times v prime plus v times u prime. Well, if we're looking specifically at an x value of 2, then y prime of 2 is u of 2 times v prime of 2 plus v of 2 times u prime of 2. And I know what all of those values are. We said that u of 2 was equal to 3. So I'm going to plug in 3 there for u of 2 times v prime of 2, that's equal to 2, so I'm going to fill that in there, plus v of 2, we said that was equal to 1, so I'm going to fill that in there, times u prime of 2 is -4, so I'm going to fill that in there. Now all I have to do is simplify things down. Well, 3 times 2 is 6. 1 times -4 is -4. If I take 6 and add -4, I get 2 as my final answer. In this example, we're going to look at finding an instantaneous rate of change. So we've got an orange farmer that currently has 200 trees, yielding an average of 15 bushels of oranges per tree. She's expanding her farm at a rate of 15 trees per year, while improved husbandry is improving her average annual yield by 1.2 bushels per year. What is the current instantaneous rate of increase of her total annual production of oranges? So there's a lot going on here. I'm going to introduce a couple of functions to represent what we've got happening in here. I'm going to represent a function t of x, which represents the number of trees after X years. And I'm going to introduce another function, which I'm going to call y of x, which represents the yield per tree X years from now. So then as far as the production per year, what we're looking at is the number of trees that we have in any given year times the yield per tree in that year. So if I'm trying to find the instantaneous rate of change of this production, I'm really trying to find P prime of x. Now using our product rule, I would have to take T of x times y prime of x plus y of x times t prime of x. Now before we can start filling things in there, let's take a look at the information that we're given. We're starting with 200 trees. So the number of trees we have right away when we start, so at a time of 0, is 200. But we also know that we're increasing the number of trees that we have at a rate of 15 trees per year. So the rate of change, that's like the derivative. So if we're thinking about the rate of change of t, the rate of change of the trees is 15 trees per year. Now if we're talking about the yield, the initial yield of the trees is 15 bushels, but then we're improving that average annual yield by 1.2 bushels per tree. So the rate of change of the yield, so the derivative of the yield, is that 1.2 bushels. So we can take all of this information from these functions that we've built and the information that we were given, and we can find the rate of change for the production using this product rule. Now we're going to be looking at this x value of 0. We're thinking about this year right now. So we're going to have to do t of 0 times y prime of 0 plus y of 0 times t prime of 0. So filling in those values that we just talked about, t of 0 is 200 times y prime of 0 is 1.2 plus y of 0 was 15 times t prime of 0 was also 15. So doing a little multiplying and adding, we end up getting 465. So the rate we're looking for is 465 bushels of oranges per year. That's going to be it for this video. Thanks for watching.